Okay, good morning friends.
Good morning, sir.
So, we are going to conduct an experiment to understand another phenomena of light. We have learned one phenomena of light, that is reflection, right? And when light is traveling in an optical medium, if it strikes the surface of another medium, then you see the light is traveling in optical medium air, it is striking the surface. So what you see here is a piece of glass. This is a piece of glass, right? And there is a line marked on this. This line is perpendicular to this edge. This is a rectangular glass piece. Okay. Now, what you see here is a ray of light is hitting this point, right? So it is the point of incidence, and then that means light is striking the surface of another medium. Glass is one medium, air is another medium. So at this point you will see a part of the light energy returning. Can you see this?
Yes, sir.
So this is the reflected ray. This phenomena we have seen. Now you can see that this glass becomes another optical medium. See, optical medium means it is the medium where light can travel. Medium where light can travel. So you can see that a part of the light energy is traveling inside the optical medium glass. Okay? Right. And then at this point again you can see at this point, right? This is the light is traveling in optical medium glass, and then again after this edge there is again air. So again this ray of light is hitting the surface between these two medium, and therefore you can again see part of the light energy which is reflected. Can you see here?
Yes, sir.
Hello?
Yes.
Okay, I hope you can see that it is reflected here. Okay? And again part of the light energy is coming out of the glass. Hello, are you able to see this?
Yes, sir.
So now we will give names to this. As you know, this ray we call it as incident ray, and then you can see that there is a line drawn on the glass, and I have kept a set square, I have kept a protractor here. This is the 270 line on the protractor, the division. This 270 line is aligned. You can see here, this line is aligned with the glass line. Hello?
Yes, sir.
Then I have kept another protractor here with a scale. So this is aligned. So you can see that this straight line is aligned throughout. So the idea here is now that this line that you see on the glass surface is perpendicular to this edge, and this line of the protractor is perpendicular to this. Are you able to appreciate that?
Yes, sir.
So then this ray of light and with respect to this line, so this line now is perpendicular to this glass edge. Clear?
Yes, sir.
So therefore now this incident ray is making some angle here. Is making some angle here. Can you tell me what is this angle? This incident ray, what is this angle? See here. This is the incident ray. What is this angle? You should tell. Don't touch anything.
15
15 degrees.
15 to
Hello.
16.
It is 15 degrees. Correct? Hello. This angle. This angle is 15 degrees. Okay? This is the angle of incidence with the normal. Then what is the angle of reflection here? Obviously, you cannot tell anything other than that. It is 15 degrees. So angle of incidence is equal to angle of reflection. Right? That is followed. Now this ray which is inside the glass surface. So what is this point? This point is point of incidence. And this ray is inside the glass. We call it as refracted ray. Kya?
Refracted ray.
Now, make sure that everybody sees. Refracted ray. Now, here, what is this angle? Further, go and measure.
Which one, sir?
This one. See this angle. Angle of the. Listen here.
Yes.
This refracted ray with this line, this angle.
And 10, sir.
Huh?
10. This and this. 10.
No, see this one, this angle. This
10.
angle. It is 10.
10.
Huh? See this red line is there, and then this is the emergent. This is the refracted ray. Okay. So what is that angle?
10.
Come closer. See.
10, sir.
10 degrees.
10.
So the incident angle is how much? 15 degrees. The reflected ray is 50 degrees. And this angle made by the refracted ray with the same normal, you can see the same normal. You are measuring the incident ray with the same normal, and with the same normal it is making 10 degrees. Hello, are you with me? So this incident ray should have traveled straight, but now it is bent towards the normal, and therefore this angle is 10 degrees. Hello?
Yes,
So, the angle of incidence is 15 degrees, angle of incidence is 15 degrees, angle of refraction is 10 degrees. So otherwise this ray of light would have gone straight, and then this ray, if it had gone straight, it would have made an angle of 15 degrees. Since it has made 10 degrees, what does it indicate?
That the angle of refraction is less than the angle of incidence.
That is the measurement. What does it mean?
Normal. The angle of refraction is not equal to angle of.
Okay, angle of refraction is not equal to. See, you should. I am training you to tell maximum truth. You are not trying to tell maximum truth. Some truth you tell and you feel it is nice. Try to tell. See, when you are having a measurement here, why you want to say this angle is less, something less than, more than, you tell no. This angle of incidence is 10 degrees. This is 15 degrees. So angle of refraction is less than angle of incidence. What does that mean? What do you infer from that? This ray was traveling like this. It entered glass. So its angle of refraction is less. What does that mean? What is your conclusion?
That the light bends by a smaller angle.
Very good. See, this is the conclusion, man. This is the measurement. From measurement, what did you understand? You understood that the light at this point has bent. Okay. See, it was going straight. Okay. It was going straight. Now it has bent. Don't you feel so?
Yes, sir.
If I tell and if you feel that is not feeling, I am telling you light is bent. See, use small words, common words. Then we will make it more sophisticated. So the light has bent here. Got it?
Yes, sir.
Isn't it a phenomenon?
Yes.
It is a phenomenon. Just like how reflection is a phenomenon, refraction is also a phenomenon. In light you had laws of reflection. Right? Angle of reflection is equal to angle of incidence. All the three, which is it? Incident ray, the normal and the reflected ray, all lie in the same plane. Here also you see the incident ray, the refracted ray and the normal. See here the normal is this. Can you see this line through?
Yes, sir.
The line through, this whole line is normal. Got it?
Yes, sir. Yes.
So the incident ray, the refracted ray and the normal at the point of incidence, all of them are in the same place. Okay, got it? Now I will slightly do something and you should see what happens. Now, what is the angle of incidence?
20.
Louder.
20.
20. What is the angle of refraction?
10. 15.
Go and see.
Only. Angle of incidence is 20 degree.
Louder. Angle of refraction is?
Refraction.
Angle of refraction is how much?
10.
10.
12, sir.
12. Angle of refraction is 12. Angle of incidence is
20.
20. So as the angle of incidence is increasing, angle of refraction is also increasing. But the angle of refraction is less than angle of incidence. And you can see the reflected ray here and the reflected ray here. So you see now, there is a corresponding change in the angle of refraction to the angle of incidence. So if I go on increasing the angle of incidence, now you see I am increasing the angle of incidence. Is the angle of refraction is also increasing?
Yes.
So there is a law. It will not increase just by itself, just by something. There is a relation between the angle of incidence and the angle of refraction. Okay? So now here we are going to understand this law. We are going to understand this law. That is what we are going to learn. Okay? Now experimentally we have established this. Now we are going to develop the theory to find the relation between these two angles of incidence. Okay? So now see, for the sake of brevity, if I remove this glass piece, see, the ray is straight. What is the angle between this normal here? See, what is this angle and what is this angle?
Both 30 degrees.
Both are?
30 degrees.
Both are 30 degrees. Correct?
Yes.
Now, I am introducing this medium in between. So I am introducing the glass in between. Now what is the angle of incidence?
30 degrees.
Angle of incidence.
30 degrees.
What is the angle of refraction?
20 degrees.
Don't you feel it has changed?
Yes, sir.
So first experiment. Now let us come outside the mirror. Now this is the emergent ray. Can you see here?
Yes, yes.
Now here I am using one more protractor here. Okay. Now here you see this edge of the protractor. This edge of the protractor are 90 degrees. Can you observe? Hello?
Yes, sir.
So this edge of the protractor is perpendicular to this surface, and this edge of the protractor is parallel to this what? Hello? Can you observe that? So this entire line is normal, and this line is normal to this. Okay, and this is the emergent ray. What is this angle? Measure. Hello? Angle made by the emergent ray with the normal. What is it?
30 degrees.
So what does it mean then? Angle of incidence and angle of emergence are?
Equal.
Don't you observe that?
Yes, sir.
That is very important. So the incident ray and the emergent ray are parallel to one another. And here only it is got refracted. Got it? And you can see that if I remove this glass piece, the ray will go straight. Okay? And what you see here is that if I make the angle of incidence 0, then this normal and the normal of this edge of this will coincide. Correct?
Yes, sir.
What is the angle of incidence?
0 degree.
Did you observe that I had to move this piece to the right by so much distance? Hello?
Yes,
Then
yes.
because this point of emergence moved from here to here. Did you observe?
Yes, sir.
So that means because of that, the normal when I am measuring this is also shifting by so much.
Yes, sir.
Understood?
Yes.
So what is your conclusion from this experiment? Think around center. So you should think about this angle of emergence, and also there is a shift in this normal. So one thing is angle of emergence is equal to angle of incidence. Angle of refraction is less than angle of incidence. And there is a shift in the normal. Can you see here? Hello?
Yes.
So that means this point of emergence, see when the light was incident perpendicular to this, the angle of the point of emergence was this. Now the point of emergence has shifted to the right. Do you observe that?
Yes,
Yes, sir.
Now if I further increase the angle, now the angle of incidence and the angle of emergence are equal. Now this much is the shift I have to do here. So that means the point of emergence shifted from here to here. Did you observe that?
Yes.
So if I increase this, this is also increasing. Right? This is what we call it as lateral shift. So the light undergoes refraction. At the emergent point, the light will undergo lateral shift. Right? So these are the observations you have to do. And yes, now you want to ask any question, you can ask. Louder.
It is not homogeneous, it is heterogeneous.
Louder.
The glass slabs, it is not completely homogeneous.
Why? Glass slab is homogeneous.
Then why does it bend like that?
See, now you understand. This glass slab is homogeneous. This air is homogeneous. Hello?
Yes, sir.
But at the boundary, it is not homogeneous. At the boundary, it is not homogeneous. Got it?
Yes.
So this boundary, at the boundary, from here to here, if you go and if you are looking at this boundary, it becomes heterogeneous.
So homogeneous in the sense it's of the same kind of medium. Right?
Yes. So this medium here is same, this medium here is same. But at the edge, the optical density will change. Only at the edge. Afterwards it will not change.
Yes, sir.
Did I clarify your doubt?
Yes.
Hello?
Yes,
Yes,
sir.
sir. Yes, sir.
So it becomes different medium. So if you stand on the boundary, then you are standing on the heterogeneous medium. Exactly on the boundary. Therefore the law is very clear. What is refraction? When light traveling in an optical medium obliquely incident. You see here? If I make the incident perpendicular, then there is no refraction. There is no bending.
Yes, sir.
Light traveling in an optical medium is incident obliquely on the surface of another optical medium, and light enters the second optical medium. At the point of incidence, the light will bend, change its direction. This phenomena, it's a phenomena, it will change the direction. Nature, this phenomena is called refraction. Got it?
Yes.
So what is refraction?
The ray of light is incident on an
No, you should follow the process. ನಾನು ಮಾರಿ ನೋಡ್ಕೊಂಡು ಹೇಳಿದ್ರೆ ಬರಂಗಿಲ್ಲ, ನಾ ಹೇಳೋದು ಕೇಳಿಲ್ಲ. ಇಲ್ಲಿ ನೋಡ್ಕೊಂಡು ಹೇಳ್ರಿ process ಅಂದ್ರೆ ನೀವು ನಾನು I am showing you experiment so that when next time when I ask you question, this experiment must come before your mind's eye, and you should look at that experiment through your mind's eye, and you should tell. You are looking somewhere and trying to tell. That's you are trying to your search engine. Look at that. Science is in action. Science is a process. Follow the process, and process means from beginning to end. Tell.
So a ray traveling in an optical medium is incident to the surface.
ಅವಸರ ಆಯ್ತಾ? ನಿಧಾನ ಹೇಳ. Correct ಆಯ್ತು ಹೇಳ. ಸಾವಕಾಶ ಹೇಳ. You are trying to hurry up. Come on, stress and tell properly. Correct. Come on, tell.
A ray traveling in an optic medium is incident to the surface of another medium.
Another optical medium. See here, when you define reflection, you don't have to say that the second medium is optical medium. See, if it strikes on the table also, it is reflecting. Why I say optical medium? Optical medium means light can travel in. You will not observe refraction phenomena on this table, which is opaque. You will observe refraction if light enters. So the second medium should also be optical. ನೋಡ್ರಿ ಇದಕ್ಕೆಲ್ಲ ಮಾರ್ಕ್ಸ್ ಇರ್ತದ. ನೀವು ಬರೇ ಸೆಕೆಂಡ್ ಮೀಡಿಯಂ ಅಂದ್ರೆ ಸುಧೀರ್ ಮೂರ್ತಿ ಕರೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ನೀವು ಮಾರ್ಕ್ಸ್ ಕೊಡುವುದಿಲ್ಲ. I will show you how to score 100 of 100, and you have to train your mind like that. Understood? Then only you will succeed. Not writing something and getting some marks. I have corrected your papers. I have not given marks, and you know how you have written. So if I award marks, you know you are going to get wonderful marks, and you will not be happy. Definitely not your parents. So I am not going to give marks and all. Over. Second test you do better. With marks I will give you. Got it? So that I don't want you to feel dejected. It's that you don't know how to write. I have taught you how to write. Next time you will write better. That is the whole idea. Correct?
Yes, yes, yes.
Understood? So now tell properly. Yes. What is refraction? Come on, I am putting you under pressure. I know that. But you should learn under pressure. Then only you can handle those examinations which are 100 times more pressure than this classroom. You understand? So it's not that I teach you very soft and then no, because you should write your examinations under lot of stress. It will be a challenge to you, that IIT exam. So you have to be very strong. Right? Now be strong and answer my question. What is refraction? Loud and clear. Fardeen, you tell. Loud.
So ray traveling with an optical medium.
With an optical medium,
Through an optical medium.
Why you are stumbling? No, you are seeing my face. What is there in my face? You see there and you be serious. You see, I have to train you, all of you. When you are telling, your focus must be on that. Your focus must be learning. Your focus is not on learning. Your focus is on what sir will do. Will it give me shabash? Will he scold me? All these voices are there. That is why you are not learning science. Your focus must be on learning, not on anything else. Correct? Your mind, your eyes, your ears, everything should focus on that. Then you will tell the right answer. Come on, whenever I ask a question, before your mind's eye you must think. Or if something is there in front of you, look at that and tell no. Now once again, be calm. Okay.
A ray traveling with an optical medium.
With an optical medium, no.
With or through.
Light with andra in hintin hitkondu hogodu with andara. I am traveling with my wife. With andara adಕ್ಕೆ through ಅನ್ನಂಗಿಲ್ಲ. ಹೇಳ ನಗ್ರಿ ಏನೇನು ಅರ್ಥ ಮಾಡ್ಕೊತೀರಿ ನಾವು ಮಾಡ್ಕೊಂಡು ಏನು ಇನ್ನೊಂದು ಡಬಲ್ ಟ್ರಿಬಲ್ 4 ಫಿಲಿಂಗ್ ಮಾಡ್ಕೊಂಡು ಅದು ಹೇಳಿ.
A ray traveling through an optical medium is incident to the surface of another optical medium.
Good.
At the point of incidence, the ray bends or changes its direction. This phenomena is known as refraction of light.
Why you hurried it? Slightly you missed. Everything is correct. 99% correct, 1%. See here, where did it bend?
At
You
the
simply
point of- No sir, I told you, sir, at the point of incident, the ray changes its direction or gets bent. Or is bent.
Ray changes its direction, saka. Bend are used, not other uses. So now it is very simple. See, how do I tell? Do I have any book? Nothing. You ask me anytime on the road also, I will tell. How will I tell? You mean to say I have by hearted? No, I can't by heart. 1000 definitions. By the time you complete PUC 2, approximately 1000 definitions. You can't by heart. Right? So, if you ask me any question, before my mind's eye, I will create that experiment. I will imagine this experiment. And I will see this experiment from the first to the last. And then go on speaking in English. Right? See, before my mind's eye, this experiment is there. Before your mind's eye also, this experiment will come. Now you see, a ray traveling in an optical medium enters another optical medium. At the point of incidence, the ray changes its course or bends. This phenomena is called refraction. Simple, correct? Now remember, the framework in physics is condition. First you say the conditions, and then under that condition you should relate the physical quantities. So what are the physical quantities you are relating?
The incident ray, the refracted ray, and the emergent ray.
No, at this point of incidence,
And the point of incident.
what are you relating?
The incident ray, the normal and the refracted ray.
So you see there and tell, don't see my face. See, don't go on seeing my face and try to see whether sir will tell nice, sir will smile at me, sir will say good. ಅದೆಲ್ಲ ಬಿಡಬೇಕು, ತಿಳಿದಿಲ್ಲ? ನಾ ಏನು ದೊಡ್ಡ ಗ್ರೇಟ್ ಅಲ್ಲ. We are all mortals. But science is immortal. You are learning science. Tomorrow you will teach somebody. Tomorrow with that you will do something good to somebody. You are leaving your legacy on this earth. That is what you have to see. Not, sir will say shabash, sir will smile. No, what is the use? Understood? So you see the knowledge. Get it, right? So what happened is, Madam Sanidhi was telling, she told the incident ray, the refracted ray, and then she looked at my face, and then she told emergent ray. If you had not seen my face, you would have seen normal. Since you saw my face, you told emergent ray. Don't see my face. Okay. So you understood the phenomenon of refraction? Now, from the experiment, what did you see? From the experiment, you observed that the angle of refraction. What is the angle of refraction?
15.
See, listen. You are all English medium students, right? How much is the angle of incidence? 15 degrees. What is the angle of incidence? See, understand, in question and answers perfect order. What is the angle of incidence means? What is meant by angle of incidence? What is meant by angle of refraction? Understood? How much is the angle of refraction? 15 degrees. What is meant by angle of refraction?
By how much the
By how much? By which? What is meant by angle of refraction? Yes, Sampath.
The angle between the normal and the refracted.
Good. What you told is correct, but you should not see me. When there is experiment on the table, you should see that. If you are seeing that and telling, then I feel you have knowledge. If you are seeing me and telling, that means I feel that you have hearted and you are vomiting. And that's the truth. Come on, all of you train yourself. Your mind's eye must be seeing physics. You have got Divya Drishti, a sight which normal people don't have, only you people have. Normal people cannot see light, but physics students can see light. Normal means, once upon a time we were also normal. That is, we didn't know force. We can't see, everybody cannot see force, but physics people can see force. How will you see force? How do you feel that there is force?
After seeing its effects.
Loud!
After seeing its effects.
After seeing its effects. Correct. That's a good answer. And if I ask you what are the effects, you should tell one thing. So, when the shape of a body changes, there must be some external force.
The direction.
When the velocity vector associated with the body changes, there must be force. And when
When the size of the object.
No, size of the object bada. Shape of the object. Size of the object much more complicated. Right? Right? And when work is being done, then also there is force. So any change for that matter, force is necessary. If you want to change from one to another, there should be force. So you see force like that. Understood? So you have to understand. So what is angle of refraction? Angle made by the refracted ray and the normal at the point of incidence is called angle of refraction. See, these definitions what I am asking you, they are all one mark questions. They appear very simple. What is the angle of refraction? Angle of refraction, sir, what that? You have to write clearly. The angle made by the refracted ray with the normal at the point of incidence. Because you can draw many normals. Anywhere you can draw normal at the point of incidence. Now you understood angle of refraction, angle of incidence. Similarly, what is angle of emergence?
Angle made by the emergent ray with the normal at the point of
at the point of emergence. Yeah, you all, nee helida nee tilililla nee help madri. I want an answer together. I appreciate. Na ibru helidantilla. But final exam baribekare obbobru baru. Samohikವಾಗಿ Okay, got it? Okay, so anything else you want to know?
Sir, I had a question.
First, please ask.
Sir, you told that there is a lateral shift. I wanted to know that what is the distance between the lateral shifted ray? I mean, the emergent ray and the normal. For
okay, now you see what you do. You draw a line from here.
Yes.
Good question. Can you see? The edge of the scale is coinciding with the emergent ray. Hello?
Yes, sir.
The edge of the scale is coinciding with the emergent ray.
Yes.
Huh? This is the emergent ray.
Yes,
Yes,
sir.
sir.
So this is the emergent ray. Can you see?
Yes, sir.
So I am aligning this scale with this emergent ray.
Yes, sir.
Can you feel that? Huh?
Yes, sir.
And this is the incident ray. Can you see that the emergent ray is parallel to the incident ray?
Yes, sir.
That is the lateral shift. एक ग्लास नहीं होता तो ये इंसिडेंट रे ऐसा जाता था. ठीक है. अभी इंसिडेंट रे और एमर्जेंट रे में देयर इज अ डिस्टेंस. दैट इज कॉल्ड lateral shift. Still you are not convinced? You tell, sir, I still have doubt. You tell, don't worry.
Can I come there?
Yeah, you can come here and see. Good.
Sir, incident.
You also can ask. You also can come. This is yours. You can come and experiment here. Feel free.
Where is the pencil?
Pencil you want? Take.
Emergent ray are equal.
Loud.
Are incident ray and emergent ray equal?
Equal means what?
They have the same angle.
Correct. You saw no angle of emergency is angle
But
of
here,
angle of emergency is equal to angle of incidence. We measured it no both 30 degrees.
but when the scale was kept, it was at a different angle.
You come here. All of you come here. I will go out of the classroom for 5 minutes. You do whatever you want and you convince yourself. Come.
It
should be
depends
same,
on the when.
So the students are conducting experiment. Good. And you can see the experiment on the screen for wider view.
Every time it will be the same angle, but if
If you have any questions, you ask.
exactly parallel, then we'll all be 0 degree only.
ये 290
But
है, ये
if
भी
it's like
290
this,
सेम
it will
है.
be here only.
इसका
If the
कितना
glass is
एंगल
not
10 है ना?
open, then normal.
10 10 डिग्री.
You have to keep it at the
11 degree.
normal
Huh.
till the.
11 degree. 11
What
12
if the glass is not
Talk,
kept at
speak
the
loudly.
normal
20
is-
degree.
she's
11
asking.
degree. 11 20.
If the glass is not kept near the normal, what will
90 degree bend होगा.
So they are all conducting experiments. Any
Yes,
questions,
sir.
students? Any doubt?
But this will be there only.
No sir.
So the lateral shift is the shift of emergent ray or the normal?
Huh. So both are there. So you have some questions which I can clarify it when I. Now you have observed there is a lateral shift.
Yes, sir.
Now I will go to the board and draw whatever we have seen, right? And then it will be easy for us to analyze and understand what exactly you mean by lateral shift.
Yes.
ठीक है? Huh?
Yes.
Right? So if you have completed experimentation, we'll go to the board.
Yes.
ठीक है?
The one is 0
Huh?
degree.
Happy?
Yes, sir.
Huh? So the students are conducting experiment. Good. And you can see the experiment on the screen for wider view. If you have any questions, you ask. Huh. Talk, speak loudly. So they are all conducting experiments. Any questions, students? Any doubt?
No sir.
So the lateral shift is the shift of emergent ray or the normal?
Huh. So both are there. So you have some questions which I can clarify it when I. Now you have observed there is a lateral shift. Now I will go to the board and draw whatever we have seen, right? And then it will be easy for us to analyze and understand what exactly you mean by lateral shift. ठीक है? Huh? Right? So if you have completed experimentation, we'll go to the board. ठीक है? Huh? Happy?
Yes, sir.
Huh? Friends, just now we conducted an experiment. See, the process is like this. We have to conduct experiment and try to see what really happens. So we have seen the phenomena actually taking place. Now we need to analyze. Right? So we have observed. So the next step is analysis. So whatever we have observed and we want to analyze, so we put it in this form. So as you can very well see, we had used a glass slab ABCD. Hello?
Yes, sir.
Now ABCD is a rectangular glass. That's it. It is a rectangular. Okay? Glass slab. That's it. Because whatever phenomena you saw, it is with respect to this. See, rectangular means AB is parallel to BC. Okay, now here, if AD is not parallel to BC, it's okay. Because those surfaces we are not using. Okay? Now, for the sake of brevity, so this medium is air and this medium inside is glass. So air is an optical medium, glass is a different optical medium. Right? Now what was our observation? The ray PQ, okay? It is traveling in optical medium air and it strikes the surface of another optical medium glass and Q becomes the point of incidence. Right? And a part of the light energy, in this case all the light energy you can see, is entering the glass. So you can see the pink color ray there, QR. So QR is the ray which is inside the glass and we call that as refracted ray. And then you see the light is coming out of the glass and you can see the ray RS. What is RS? RS is the emergence. And at the point of incidence and at the point of emergence, I have drawn two normal to the surface. So you can see this is normal to QC, this is normal to AB. And now we have seen the measurements. We have seen the measurements of the angle of incidence, angle of refraction, and angle of emergence. We have measured this angle. And what we found was angle of refraction is lesser than angle of incidence. Angle of refraction is lesser than angle of incidence. You can see that the incident ray would have travelled along this dotted path. But for the glass slab, if the glass slab was not there, then the incident ray PQ would have travelled along this dotted path outside. Now because of this glass slab, this ray instead of travelling here is deviated. You can see here, this is deviation. This angle is deviation. The ray which was travelling like this has now deviated. Can you see that?
Yes, sir.
That means it has changed its course. It has bent. Right? And this phenomena we call it as refraction. Right. And what we noticed was the angle of refraction is less than angle of incidence. But the angle of emergence is same as angle of incidence. What is that meaning of what does it mean? You see here, this line normal and this normal are normal to QC and AB is parallel to QC. Therefore, this normal is parallel to this normal. Correct?
Yes.
Hello?
Yes, sir.
This normal is parallel to this normal and therefore now what you need to see, what we have measured is that this angle of emergence is same, this angle of incidence is same, etc. You have seen.
So, sir, means when the light travels in again in the same medium, again it makes the same angle, equal angles.
It is making equal. Angle of emergence is same as angle of incidence.
Yeah.
I hope you understood this.
Yes.
Now what you have to see here is that see this ray and this ray are parallel to each other. The emergent ray and if I extend this incident ray, they are parallel to one another. So this shift we call it as lateral shift. Yes, sir. This shift is what we call it as lateral shift. Yes, sir. Okay. So what you see, what you have to observe here is you see now if you had put a pin here and if you had put a pin here, if you had put two pins here and then this glass slab was not there, where will you keep your eye to see the pin? That is, if you put one pin here, second pin here, and if you put third pin here, if you put fourth pin here, and if you see the four pins from here, how many pins you will see?
One.
Loud!
One.
Only one pin. Got it?
Yes, sir.
Hello?
Yes,
Ah. Now you put the glass slab and you put these two pins. Now I want to put two more pins and I should still see only one pin. Where will I? So where? See, now I want to see these two pins. So what should I do to see these two pins? If I keep my eye here, can I see? No. If I keep my eye here, I can see. And here, if I keep two pins, then how many pins I will see? One. Got it? So that clearly says that that your eyes has shifted from here to here, or your eyes has shifted from here to here. So you are seeing it like this. Now if you want, then I keep the glass slab. Then the same thing, if I have to see, I have to shift and see. Lateral shift. ऐसा देख सकता था. अभी glass slab आ गया, तो मुझे वो पिन नहीं दिखा रहे. So what should I do? I should move like this. Now I can see the pin. क्यों हुआ ये? Because light has laterally shifted. You get the whole idea now? Hello? Yes. Now I shall introduce what you have seen through the experiment is angle of incidence is equal to angle of emergence, and angle of refraction is less than angle of incidence in this case. Correct?
Yes.
Hello?
Yes,
Now what is, see, this angle is R. What is this angle?
It's a reflected.
See, you didn't see. Now if I ask what is this angle? What is this angle? Okay, now I'll ask you a question. You have measured this angle, you have measured this angle. Okay, you have measured this angle. What will be, if you measure, what will be this angle?
It should be equal to the angle of refraction.
It should be equal to angle of refraction is a quick answer, and that is correct. Why? Geometrically, you see, this is parallel to this, and this line is connecting these 2 points. So these two angles becomes alternate angles.
Yes, sir.
Got it now?
Yes, sir.
So here you see, here for the ray entering from this medium to this medium, this is the angle of incidence, this is the angle of refraction. But for the ray entering from this medium to this medium, this becomes the angle of incidence, this becomes the angle of refraction. Got it?
Yes, sir. Yes, sir.
Now, what is your conclusion here? Conclusion means the ray is entering from this medium to this medium. Glass is more optically denser. क्या बोला मैंने? Optically denser. See, there are two things. Mechanically denser. You know what is density? Mass. What is density?
Mass by volume.
Wrong. What is density? Loud. He confidently told, but not correct. Sudheer Murthy will not give marks. What is density?
The weight of an object per area.
No, still very wrong.
The mass concentrated in a particular small.
It is a measure of the concentration of mass. Correct. But then you define it mathematically. You say density is mechanical
mass
density.
per unit volume.
No, I will not give mass. You see, students, watch out. All of you very confidently have told mass upon volume. What is so great about it? I have written so many examinations. Suddenly you find in PUC 2, you go home and tell I am going to get at least 98. Then you get only 88. कहाँ गया? Revaluation वगैरह. So you would have written mass upon volume. In book also it is given, here also it is given. But in book it is not given like that. It is given very nicely. You are not read it properly. You are not understood it properly. Mass density is the ratio of the mass of a body to its volume. See, ratio का मतलब है ये ज़्यादा हुआ तो ये भी ज़्यादा होता है. What is the density of 1 kg gold and what is the density of 1 gram gold? Are they different? Hello?
No, sir.
They are different, eh?
No, sir.
Same, no? Density is same. Why? More mass, more is the volume of gold. So their ratio remains same.
Yes, sir. Yes, sir.
So the word ratio is very important. Density is the ratio of the mass of a body to its volume. That is mechanical density. Anyway, We'll come back to that. Come back, I don't know. So, but here optical density, right? It is more optically denser. You will understand the meaning of optical density shortly. Okay, so now glass is more optically dense. Air is less optically dense. So now here the light has entered from and air is optically less denser than glass. So we call this air as rarer medium. What is the word we use? Rarer medium. And with respect to this rarer medium, the glass becomes denser medium. Rarer medium, denser. Getting students? Yes? So now here you see in general, the ray is entering from rarer medium into denser medium. And what did you observe? It
Changes.
loud.
It changes its
It
direction.
changes. Now tell more truth.
Changes its direction, forming a less angle.
More truth properly. Now don't look at my face. You will not get the answer.
Changes its path at the point of incidence.
Correct. At the point of incidence, I understood.
Making a small angle.
It bent towards the normal. When the ray entered, when the light entered from rarer medium to denser medium, the light bent towards the normal, isn't it? It bent towards the normal. Same thing you see, the light traveling from denser medium to rarer medium. Hello?
Yes, sir.
See, this ray, denser medium to rarer medium, right? This ray. Did you see now here? See this ray. This ray. This refracted ray would have traveled like this. Now the refracted ray is not traveling like this, it is traveling like this. So it bent away from the normal. You should observe this. See, that's what I say. Keen eye. Kya bolte keen eye ko? Whose observation is very good. Right? So what is your conclusion here? When light ray travels from rarer to denser, it bends towards the normal. When light ray goes from denser to rarer medium, it goes away from the normal.
Yes, yes, sir.
Right? And there is a lateral shift of the light. Emergent ray is equal to angle of emergence is equal to angle of incidence. These are all the observations from the experiment that we conduct. Okay? Okay, fine. So this is first experiment. Frankly speaking, when you go to higher classes, you will conduct this experiment with different types of optical medium. Water is also an optical medium. Glass is also an optical medium. NE is also an optical medium. Oil, N. Okay. It is also optical medium. So you can see wherever light can enter, it become optical. Our eyes are the beautiful eyes are also optical medium. Correct? Wherever light can travel, it becomes optical medium. All your eyes, right? So that is the truth. Now, each of this, see, in glass only you have got varieties of glass. Glass is also optical. See, instead of this glass, if I had used water medium, then what would I have? That means now, you see, our next task will be to determine this angle of reflection, angle of incidence. What is the relation between the two? What is the relation between the two? Right? Now, my dear students, I am going to define a physical quantity. I am going to define a physical quantity. Please appreciate and understand. See, your name is defined by your parents based on some theory, some inputs there. So in science also, it's, many concepts started getting defined, right? And in the process, many we are able to explain science. So right now, I am going to define one physical quantity, right? So what is the definition, right? So here you see, I would like to know something. What is that something? Now you see, if I keep this medium of glass here, then this angle of refraction here is something. Instead of this glass, if I keep water, then the angle of refraction will be different. In fact, the experiment that I have to conduct is I should use different materials. Glass only you will have so many varieties of glasses. So if you experiment with different varieties of glass, What am I doing now? What am I doing? Louder.
Teaching.
Don't worry, get it. So if you are going to experiment different types of materials, then you see, keeping the same angle of incidence, the angle of refraction will be different for different materials. What did I say? Understood now? For the same angle of incidence, for different materials, the angle of refraction will be different. What does this experiment prove?
That the angle of reflection is because of the changing, it changes according to the density of the optical.
Very good. See, she is able to abstract. Second time today in the class, as soon as I ask the question, she abstracted. I want everybody to do this. So, in the first experiment, angle of incidence changed, angle of refraction changed. Same material. Experiment number 2, same angle of incidence, different materials, angle of refraction changed. So, angle of refraction will depend upon what? Angle of refraction will depend upon what?
Either on the angle of incidence
Angle of incidence
or the medium.
and also on the material of the medium or the optical density of the medium. It will also depend. Clear? Now,
So in both will it be closer to the normal or it may change?
if the material I am using here is denser than this material, then it will always be closer. If this medium is more denser than this, then this will be closer. If this medium is denser than this, it will come closer. If this medium is rarer and this is denser, then it will move away. But by how much it will move, that depends upon the material. So here, see, please understand. What is density in mechanics? Density is the measure of how much the matter is packed within the given volume, or it measures the heaviness. See, 1 kg cotton, 1 kg iron, which is more heavier?
Iron. Both are
Whose mass is more? 1 kg iron, 1 kg cotton. Whose mass is more? Both mass are same, equal. Whose weight is more? Both weights are same. M into G. But you know that iron is heavier than cotton. Hai ki nahi?
Yes, sir.
Why? Because the matter in iron is more densely packed. It is more closely packed than cotton. So, a figure of merit which measures a figure of merit. See, your marks is a measure of your hard work, your intelligence. So, marks is not equal to your intelligence. Marks is a measure of your intelligence. It is not equal to. See, I tell, ಕುಲವನರಿಯಿತು ನಾಲಿಗೆ. ನೀ ಹೆಂಗ್ ಮಾತಾಡ್ತಿ, ನೀನ್ ಹೆಂಗ್ ಆಚರಣೆ ಅದ, ಅದ್ರ ಮೇಲೆ ನಿನ್ ಖಂದಾನ, ನಿನ್ ಯೋಗ್ಯತೆ ತಿಳಿದು. ನಿನ್ ಮಾತ್ ಮೇಲೆ ಹೇಳ್ಬೋದು, ಇವ್ ಯೋಗ್ಯತೆ ಇಷ್ಟ, ಇವ ದನ ಕಾಯವ, ಇವ ಚಲೋ ಅವ, ಇವ ಕೆಟ್ಟ ಮನುಷ್ಯ, ಇವ ಚಲೋ ಮನುಷ್ಯ. Depending upon your speech, depending on how you speak. It's a measure, it is not equal. Hunger, density is a figure of merit. So here I am going to introduce one more thing which is a figure of merit. What is the figure of merit? We will call that figure of merit by a name called refractive index. What is the name? Refractive index. Refractive index. So refractive index is a figure of merit which will tell you how much will the light bend. If I want more bending, then I have to use a material of high refractive index with respect to the surrounding. Hello, with respect to the surrounding. You got it? See the refractive index of a material will not depend upon itself. It will also depends upon where you are keeping it. See, now I will tell you. If you are considering light is traveling in air, and then if you keep glass, then it will bend by some amount. Hello?
Yes, sir.
It will bend by some amount. So the same light, it is traveling, then instead of glass, if you are allowing to go it in water, you are allowing it to go in water. Okay, this is water. Then the amount of bending here will be different.
Yes.
Is the same glass if I keep it in water. Glass in water. एक water है, water में glass. Then the refractive index of this glass with respect to water is different. The refractive index of glass with respect to air is different. So it depends upon the surrounding medium. Understood now? So refractive index is not absolute. It depends upon the medium. Got it?
Yes.
Hello?